Hey y'all, Data Guy here. And today we're going to be going through a really cool Airflow tutorial that some of my colleagues, Tamara Fingerlin and Kenton Dennis, created on how to get started with Apache Airflow. Not only just getting started, because there are a billion getting started courses out there, guys like Mark Lamberti, but a really functional one. In this one, you're going to learn a real world use case of, doing some extraction, pulling in it from an API, getting some weather data, storing it in a database, in this case, a DuckDB, and then doing some visualizations on that data using a Streamlit app. And Streamlit is basically just a Python package that allows you to create applications that will display your data as a dashboard. So you can kind of think of it as a hyper lightweight Tableau that just allows you to, in a similar way to Airflow, run a local analytics dashboard in your browser, but just running on a VM on your desktop. So everything within here is open source. There's no accounts you need to get. There's nothing you need to install other than just taking this full repository. So to download it, you can either use a GitHub code space, and this is basically just hosted VS Code on GitHub. If you're using it, make sure you configure it with 4 cores, or you can use a local development environment. And with that, it's as every Airflow or Astro project, where you're just going to be downloading a zip or using, just the GitHub actions or the clone actions to download this repository to your desktop and then running Airflow there. Since I love running Airflow on my desktop and Codespaces is a little bit buggy, I'm not downplaying it at all, but it is just, if you lose internet access, it'll wipe your entire code space. So we're going to not use that and instead go to handy dandy VS Code today. And so now that I've kind of set the stage, let's get started. So what this looks like to start, as I said, you're going to download this whole repository here, open it on your desktop, which I will do in a second. And then you're going to follow the instructions within this guide. So I'm just going to do the actual work without following along the instructions, so I'm not just hopping back and forth. But if you want to follow along at home, definitely pull the instructions up, and it gives you a really easy way to just kind of have a reference point versus just repeating the same section of the video over and over again and listening to my voice more than you might like to. So here, getting set up, download it. This will kind of just explain to you that process, and then within Part 1 instructions, obviously, we have the instructions to get started. So the first thing we're going to be doing is entering some variables for our own name and our city so that we pull the weather information for our actual city. And then we are going to run some DAGs. And I'll explain what's cool about those DAGs that we're going to run is that they're going to be run via data sets. So other than start, none of these other DAGs are actually scheduled via a time. They are all scheduled via data sets, so that when start creates its first data set, getting some of that weather data, it's going to then, when that data set appears, trigger downstream data sets based on that data set being created. And this is why I wanted to make this video, is to show the power of having data set driven scheduling, where you're not reliant on time-based or even task-based scheduling. Instead, now I don't have to try and guess when that data is going to be ready before my next task kicks off or my next DAG kicks off. I can actually just create the DAG, create the task, create that data set, and have that as a trigger to any downstream actions. So really cool feature, and that's, again, why I wanted to make this, because it's a newer feature and not enough people know about it. It's really awesome. And then we're going to open our Streamlit app and look at it. So let's go into VS Code and start making those changes. So now that we're in VS Code, the first thing we're going to want to do is build our environment so that we can actually start writing some DAGs. So with that, all we're going to do is type in Astra dev start. If you haven't installed the Astra CLI, you'll need to do that, but just Google install Astra CLI. It'll be the first option to come up. And then we'll get this Airflow starting up message. So this is going to take about 2 to 3 minutes. So I'm going to take a quick cut and then come back when this is up and ready to go. And now we're off to the races. So we've got everything starting up. And while everything is finishing provisioning, let's make those changes that they talk about in the instructions. So the first thing we're going to do is go to our include folder, then open global variables, and then open user input variables. So here is where you're going to input your name, as well as the city of your birth, or whatever city you want, I don't really care, as well as what you consider to be a hot day in Celsius, and your birth year. So the instructions will say just to set these first 2 variables. but I figure while we're here, why not just set them all and then avoid having to go back later. So do that, save it, and then we're gonna go to the Airflow environment and start triggering our DAGs. So here, we're gonna sign in with our classic credentials, admin. Again, super secure. And you see I have my environment up and running. So what you're gonna wanna do is actually unpause all of these, so I'm gonna unpause them, pause them, and now what you'll wanna do here is select all of these part 1 DAGs, select start last, and then what start will do, if it triggers here, and if it doesn't trigger, just hit play on the side. So let me change my screen size. So hit trigger DAG, don't need to use a config, and this will start the start DAG, and then it'll also start these other 4 DAGs in a second. So if you can see, now this DAG has been triggered because if we look at the datasets view, the start DAG, let me zoom in here, is creating a dataset, which is then causing this extract historical weather, extract current weather, and in-climate data to be triggered. And so what that looks like on the DAG level, if we go to extract current weather data's code, is we can see that the schedule is based on the start dataset. And now I've given you a little bit of a hint for part 2 from here. So now you've seen all the DAGs running, let me show you your code, or not your code space, but your Streamlit app. So if you type in localhost 8501 on your top dashboard or your URL bar, enter it here and you'll see your introduced your Streamlit app. So this will show your global surface temperatures over the decade, but then if all of your DAGs are run right, it should show the current weather in the city you defined within that user variables Python file. So here, basically what we're doing is taking that city name, feeding it into a meteorological API, and that's pulling out our current weather for London data. So now that we've got part 1 down, let's move into part 2, which is a little bit more exciting. So now that we're in step 2, let's get out of our include folder into the DAGs. So the first data set that we want to drive one of our DAGs is the extract historical weather data set to have the start DAGs data set trigger it. So within the start data set, what you'll need to make sure, and this is just giving you the context so you'll know how to do this in the next one, is defining the output of start as a data set. So you can see this is going to say, hey, outlets from this create DuckDB pool is a start data set. So this is actually just creating an empty DuckDB database. And then within here, you'll have to initialize that same start data set as well so that you can use it as a variable within this DAG, while also making sure to include the from Airflow include dataset or import dataset. And then within the schedule of the DAG, you will put start dataset within brackets. And this will tell this DAG to start as soon as start dataset has been created, in this case, that empty DuckDB database. Now, the next task in exercise 2 is to have transform historical weather data run after historical extract weather data has completed and created that data set. So as you'll notice here, there's no extract historical weather data set that we've defined in the same way as the start data set. Instead, what's happened here is that at the end of this DAG, we're using an output table with kind of a Jinja-esque output definition as at table. And so what this is coming from the Astro SDK using an AQL data frame that basically allows you to take this list of JSONs and immediately turn it into a DuckDB readable table. So here, output table, table name equals C dot, and then GV dot connection to DuckDB. And these are basically just saying, hey, this is where this database is being stored, this is the name of the database, and then initializing it as that dataset's object, similar to how the start dataset was initialized as an object. This is just a different way, and that's why it was done in this way, is so you can see the 2 different varieties of ways you can define datasets and then use them downstream. So the advantage of this way is that you don't have to have that start dataset equals dataset at the top of your DAG and in every other DAG. You can just reference it within transform historical weather data, like so. So you can see I have table equals extract historical weather dataset. So I am still having to do a little bit of dataset definition. I don't have to do it in the source file, but I do have to do it in any consumer DAGs. And I realize I haven't explained this, but a producer dataset DAG is one that produces a dataset, so the start data DAG. And then any consumer DAG is any DAG that consumes that data. So anything that takes that data set and uses it as an input to trigger any downstream actions. So here we're setting that data set as from that table, and then again, similarly using it as the schedule here. So that's exercise 1 in part 2 done. So let's go look at what that looks like in our Streamlit app. So before we actually go to our Streamlit app, make sure that you go to your Airflow environment, trigger these 2 DAGs, and then run your start DAG again. So once you've done this, this will again kick through all the same actions as it did before. You can see those starting to run. And since I've already run these, my data Streamlit app is already populated. So I can go in here into Streamlit and look at my days over 30 degrees Celsius per year. So that's, again, that value I defined earlier. I'm from England. Anything over 30 degrees is boiling hot to me. So you can see I have Bern here, London, and so this is the graph that you're trying to generate. Now, the second piece of this and how we're going to expand it, so you might have noticed your graph won't have a drop-down menu by default. It'll just show whatever your initial city was. So that brings us to part 2 of exercise 2. So for part 2 of exercise 2, we're going back into the DAGs. And this time, we're going to implement dynamic task mapping. So what dynamic task mapping is it allows you to basically take a list of inputs. So let's say, in this case, it's going to be a list of how many cities I want to pull weather data for. And then instead of just running all of that collection within one task, it'll actually create 3 separate tasks that ingest that weather data for each city. So what this looks like to implement is going into the extract historical weather data and then transform historical weather data. So you can see in exercise 2, this is the first step you're going to need, is setting your coordinates equal to your get long, city, expand, city, Bern, London, and New York. So when you see it initially, it'll just say get coordinates, get long, lat long for city, and then your city is Bern. Now, with this dot expand argument, what this is doing is telling the task to do exactly as I just described. Create one task instance for each of these 3 cities and pull the coordinates for each of these 3 cities. Now, downstream of that, since we've gotten the coordinates for every 3 cities, we now need to create an individual task for each city to get the historical weather for that city. So here, what we're doing is expanding, and then we're just passing whatever the output is of these coordinates. So it automatically reads that coordinates is actually going to create 3 task instances, and then it'll create 3 historical weather task instances to accommodate that. So really powerful dot expand decorator. And if you want to keep some variables the same across all tasks, then you'll add dot partial and put any arguments in there that you want to be common across all of your tasks. So you do have flexibility in there. It doesn't have to be one task for each variable that changes. And then we can go back to our Streamlit app and see what that looks like. So back within Streamlit, you'll now be able to see, hey, I have Bern, London, and New York all available here. And so now I'm able to visualize for all 3 of those cities. So really easy to implement dynamic task mapping once you know how it works, but conceptually, it does take a little bit to kind of wrap your head around to say, okay, this is how, I'm creating 3 different task instances, one for each of these. But it really is powerful because it allows you to do all of your data processing in parallel rather than sequentially all within one big monolithic task. And also reduce blast radius, as we all like. So now let's go back into our VS Code for the final part of this exercise. And so this final part is a little more choose your own adventure. So you can kind of, whatever you want to do here, you can. Because what we're doing is taking a data set of all that historical weather data and then doing some manipulation on it to actually visualize, hey, what were the hottest days in each of those cities in our birth year? So for me, 1997, aging myself super poorly here. And so when you log in here, when you're coming from a fresh file, you actually won't see all these transformations made. So if you don't want this spoiled for you, look away, avert your eyes, hear no evil, see no evil. But here you can see that I've actually written a transformation that is reading each birth year, taking every birth year, grouping the data by city. So saying, hey, for my birth year, take the data from that city from that year, and then find the highest temperature within that year, and then renaming the columns, just say hottest day because I've already grouped them, so I don't need to actually drop or rename anything, or not rename, but I don't need to add anything. I'm just basically change the configuration, filtering things out. Then I'm selecting those columns, showing them that I'm going to show in the output table, and print the result. So you can do your own type of transformation. I've seen this done many, many ways, and that's kind of the point, is within an AQL data frame, which is part of that Astro SDK I mentioned, you can do any kind of pandas transformations and then read that data between any subsequent tasks as a SQL data frame, sorry, not a SQL data frame, SQL data set, without needing to do any transformations. So this output DF can be read and imported directly into a SQL function. So really cool function here. I won't go too deep into it because it could deserve a whole video on its own, but Astro SDK, super powerful. Check it out. And so what this looks like now that we're all done, so we can go back to our Streamlit app, scroll down, and now we can see the hottest day in 1997. So for Bern, London, and New York City. And I was born in London, so pretty cool seeing that the hottest day was actually under what I consider a hot day. So it's a pretty temperate year for old London. So that's the end of the tutorial I had for you today. I really hope you guys enjoyed it. It is super fun to go through and do. It doesn't take a lot of time. It's a great way to understand some of the newer Airflow concepts and get you up to speed on how to really make use of them in a functional and productive way. So I hope you learned something, and as always, have a good one.